Welcome back. In the next part of this lecture, we're just going to do some more examples of graphing transformed sine and cosine functions. So we'll have a function here, y equals negative 5 cosine 3x plus 2 pi. And the first thing that I'm going to do is just rewrite this by factoring out the 3. So 3x plus 2 pi, when I factor 3 out, that's 3 times x plus 2/3 pi, or 2 pi over 3. So we know here that the phase shift is negative 2 pi over 3, or 2 pi over 3 to the left. So I know that after I've looked at my basic trig function, I'm going to then be shifting everybody to the left by negative 2 pi over 3. Now here, I don't have to do anything to simplify further, because you'll notice that the number 3 that I have here is already positive, so I don't have to use the even property of the cosine function to simplify further. This is already as nice as it's going to get. So I'm going to look at the simpler trig function, the one without a phase shift, y equals negative 5 cos of 3x. And for that, I can find that the period is 2 pi divided by 3. And so that means that the length of my subintervals needs to be 1/4 of that. And 2 pi over 3, when I slice that into 4 equal-sized pieces, that gives me pi over 6. So that means that if I'm thinking about my x values that I have, it should be 0, then pi over 6, then 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, and then finally 4 pi over 6, which is 2 pi over 3. So now I've got all of my x values for my basic function. And now I can put in all the y values. For cosine, we start with that coefficient. So negative 5, then 0, then the opposite of it, then back to 0, then back to negative 5. All right, and so for these, I'm going to be now doing my phase shift, and I'm going to do that by subtracting subtracting 2 pi over 3, or adding negative 2 pi over 3 to all of my x values that I have there. So the y values will remain unchanged. The only thing that will change will be the x values. And so, like I say, what I'll be doing is taking each of my x values that I have, and I'll be subtracting that phase shift. That 2 pi over 3 will be subtracted from all of my x values. So my first x value is 0, and 0 minus 2 pi over 3 is negative 2 pi over 3. For the next one up, the next x value, which on the previous page I had as pi over 6, and pi over 6 minus 2 pi over 3, I can see as a fraction should be negative pi over 2. The next one that we had up was pi over 3. Pi over 3 minus 2 pi over 3, that's negative pi over 3. Then finally we had pi over 2. Pi over 2 minus 2 pi over 3. So pi over 2 minus 2 pi over 3, that is negative pi over 6. And the last one, which was 2 pi over 3, and 2 pi over 3 minus 2 pi over 3, that is 0. So for all of these x values that I'm having here, I did all of my calculations for them in the following way. So for example, for this one, the negative pi over 2, which I found by taking pi over 6 and subtracting 2 pi over 3, how I found that this was negative pi over 2 was I thought of it as 1/6 minus 2/3. And using your calculator, you can find that 1/6 minus 2/3 is negative a half. So that means that pi over 6 minus 2 pi over 3 should be negative pi over 2. And that was the sort of thinking that I was doing when I was finding all of those x values by doing my little subtractions. So there we go. We had a phase shift of negative 2 pi over 3, or 2 pi over 3 to the left. So we subtracted 2 pi over 3 from all of our x values. And so now we're ready to start plotting. We had negative 2 pi over 3, negative 5. Negative pi over 2, 0. Negative pi over 3, 5. Negative pi over 6, 0. And 0, negative 5. There we go. So our shape of one cycle of our trig function should look a little something like that. And then if we wanted to draw a second cycle, there we go. So our y value is going to 0, then to 5, then back to 0, then back to negative 5. Trying to make this look a little less pointy, and there we go. All right, so now we just need to label any of these points that are not at tick marks on the x or y axis. So I've got 2 pi over 3, negative 5 that needs to be labeled. There's pi over 3 and 5 that needs to be labeled. There's also negative pi over 3 and 5 that needs to be labeled, and then also negative 2 pi over 3, negative 5 that needs to be labeled. And there we go. So this is the graph of my trig function, which is the graph of y equals negative 5 cosine. And this, again, you can label it however you prefer. You can either label it in the original way that it was written or in the factored way, whichever you like best. I'm going to go again with the original way, negative 5 cosine of 3x plus 2 pi. And there we go. There is my trig function, nicely graphed. All right, let's do another one. This one has two kinds of shifts. There's a phase shift and a vertical shift. So rewriting this first in factored form, I've got that negative 2 cosine of 3 times x minus pi over 3 plus 2. All right, so there's a vertical shift of plus 2. There's a phase shift of pi over 3, positive pi over 3, or pi over 3 to the right. I also can see for the cosine function, this number is already positive, so I don't need to do anything with the even properties of cosine to make that better for me. So we're already pretty much good to go. We just need to start with our basic stretched cosine function, the one that has a vertical stretch and also a horizontal stretch. And once we find the key points for that, then we'll apply our two shifts, adding pi over 3 to all of the x values and adding 2 to all of the y values. Okay, so starting off, we have the period for this should be 2 pi over 3, and that means that the length of my subintervals should be 1/4 of that, which is pi over 6. And so for our x values, starting at 0 and going up by pi over 6 each time, so we have 0, pi over 6, 2 pi over 6, which is the same thing as pi over 3, 3 pi over 6, which is the same thing as pi over 2, 4 pi over 6, which is the same thing as 2 pi over 3. And there we go. Those are all of our x values. And our y values, starting with -2, then 0, then 2, then 0, then -2. Okay, so we've got most of everything ready to go. We just have to now do our 2 little shifts. So what we're going to need to do is take the x values that we had before, and we're going to be adding pi over 3 to all of our x values. We're adding because this is a phase shift of pi over 3 to the right, so this is shifting our graph to the right by pi over 3. And so we're going to start by taking all of our x coordinates and adding pi over 3 to them. So the first one was 0. 0 plus pi over 3 is pi over 3. The next one, which was pi over 6, pi over 6 plus pi over 3 is pi over 2. Then the next one up after that, we had pi over 3. Pi over 3 plus pi over 3 is 2 pi over 3. And then the next one after that was pi over 2. Pi over 2 plus pi over 3 is 5 pi over 6. And then finally the last one, which was 2 pi over 3. 2 pi over 3 plus pi over 3 is pi. There we go. And now the next part was to take our y values and add 2 to all of them. -2 plus 2, that's 0. 0 plus 2, that's 2. 2 plus 2, that's 4. 0 plus 2, that's 2. -2 plus 2, that's 0. So we've got now 5 key points for one cycle. And let's start graphing. We have pi over 3, 0. We have pi over 2, 2. We had 2 pi over 3, 4. We had 5 pi over 6, 2. And pi, 0. And if we want another cycle, we just need to repeat that pattern. So from that point, pi over 3, 0, the y values would go up to 2, then up to 4, then down to 2, then back to 0. And now we just need to label any points that we have. So I've got 5 pi over 6, 2. I've got pi over 2, 2. There's 2 pi over 3, 4. There's pi over 6, 2. There's negative pi over 6, 2. And there we go. I think I've labeled everyone. Yes, all the other points are all at tick marks, either on the x-axis or on the y-axis. And so there we go. We can now say what we have. This was the function y equals -2 cosine of 3x plus 2. I might not be remembering this correctly. Let's read this correctly. No, it was negative 2 cos 3x minus pi. I knew there was a mistake somewhere. 3x minus pi. There we go. Plus 2. That's the correct function. So there we go. We've got our graph labeled with all the important points labeled, and we are finished. Okay, so one last one to do, and this one we're just going to do one cycle of it, so we will be happy. A little bit less work for us to do. This one first, I'm going to start by factoring the negative 4 out of every one. That's inside the sign. So instead of sine of negative 4x plus 3 pi, I'll have sine of negative 4 times x minus 3/4 pi. And there's the minus 1 outside. And I do have a negative here, so I am going to need to use the odd property of sine and say that actually 3 sine negative 4 times stuff is the same thing as negative 3 times sine of positive 4 times x minus 3/4 pi minus 1. Okay, so this is something where we're going to have to deal with both a horizontal shift, a phase shift of 3 pi over 4 to the right. We've also got a vertical shift of negative 1 going down by 1. And before we do any of that, we're going to first look at our simpler function, negative 3 sine 4x. And for that one, the period is 2 pi divided by 4, which is pi over 2. And the length of the subintervals should be 1/4 of that, or pi over 8. So for our x values, starting at 0, going up by pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, and there we go. So those are all of our x values. And our y values, it's a sine function, so we start at 0, and then going to that coefficient of negative 3, then back to 0, then back to 3, then back to 0. So this is negative 3 sine 4x. That would be the 4 key points, or the 5 key points that we would graph for those. And now if we're looking at the function that we're actually interested in, which is this y equals negative 3 sine of 4 times x minus 3/4 pi minus 1. I'm going to have to do two things here. One is that I'm going to have to do a phase shift of positive 3/4 pi. I'm going to be adding 3/4 pi to every x value. And I'm also going to be subtracting 1 from every y value. So my x values, we had 0, pi over 8, and so on. All I'm going to be doing here is adding on to each one of those 3 pi over 4. And so away we go. We have 0 plus 3 pi over 4. That's 3 pi over 4. Pi over 8 plus 3 pi over 4 is 7 pi over 8. The next one up was pi over 4. Pi over 4 plus 3 pi over 4, that would be pi. So we've done the first three, 0, pi over 8, pi over 4. The next one up, 3 pi over 8 plus 3 pi over 4. And when we add those together, we will get 9 pi over 8. And then the very last one that we had, which was pi over 2. pi over 2 plus 3 pi over 4. When we add those together, we get that those are 5 pi over 4. There we go. We've got all of our x values. And now for all of our y values, taking those y values and subtracting 1 from every one. So -1, then -4, then -1, then +2, then -1. All right, so we've got our 5 key points. Let's start plotting. We have 3/4, -1, 3 pi over 4 rather, -1. We have 7 pi over 8, -4, pi, -1, 9 pi over 8, +3, 5 pi over 4, -1, and there we go. There would be one cycle of my trig function. And here all I wanted was one cycle, so I don't need to do a second one. I mean, you certainly can if you want to for fun, but you're not required to here. All we had is one cycle that I wanted, so all that I really need to do now is just to label all of my points. It looks like all of my points, all 5 of them, are going to need to be labeled because none of them are at tick marks on the x or y axis. So there we go. I've labeled all 5 points, and now the only thing left for me to do is label it with the equation itself. And again, you can label it with the original equation or the factored version, whichever you prefer. I'm going to go with the original one here. So that's 3 sine -4x plus 3 pi. And then -1. And there we go, just double checking that I've got the correct equation. 3 sine -4x plus 3 pi minus 1. Yes, I do. Good, so it's been labeled, and all the important points have been labeled, and there we go. That is the one cycle that I was hoping to graph.